All right, hi. Today we're going to look at good graphs. So, what are we learning? We're going to learn the purpose of graphs, characteristics of a well-made scientific graph, and some shapes of graphs of some basic algebraic functions. Our essential question is fairly simple. What do graphs tell us? So why graph data? So graphing tells the story of the data. It helps us visualize the variation in the data, and it shows relationships between variables, and perhaps we'll be able to model these to some basic functions. I'd like to start off by looking at a bad graph. So this one tells us deaths due to cigarette consumption. We have deaths on the horizontal axis and consumption on the vertical axis. So what does this tell us? Well, it doesn't tell us a whole lot. There are no units on anything here. And in general, we have to say that deaths don't cause cigarette consumption. We think that cigarette consumption causes death. So the independent variable should be here on the horizontal. These two axes are flipped. And notice how we don't really have a trend line. You kind of connected the dots. This thing goes all over the place. So we can't really tell what these two have to do with each other. Let's make some improvements on this and see if we can now tell the story. So what does this tell us? Well, first, we're putting labels and units on both axes. It has a trend line or a best fit line, so we can tell what the trend is. We've put the independent variable on the horizontal axis. That's going to be, and in this case, consumption of cigarettes per person per year. Changes in this one causes the changes in the dependent variable, which is now on the vertical axis. This is changing because of the changes in the independent variable. All right, so now we can look at this and hopefully tell a story here. So let's just pick one piece of data here, say at 400 cigarettes per person per year. We read it up here, oops. And we notice we have about 100, 20, 40, 60, 160. If we increase the consumption here, what happens to the deaths? Well, it goes up. It goes up to 200, 20, 40, probably about 60 or so. So as consumption gets bigger, deaths get bigger. There, we've been able to tell a story. Let's take another look at this idea of a trend line or best fit line. This is also a pretty good graph too. It has labels and units on both axes. It has a nice trend line. The data spread out over both axes. We're using all the space here. This is very nice. And notice what this line does is it shows us what the relationship is between the independent variable and the dependent variable. Notice that it doesn't touch every single data point. This is what a trend line will do. It doesn't need to touch each one of these. It's giving us the big picture of things. In real life, data will vary somewhat for all sorts of different reasons. We're stepping out of the textbook here. So let's take another look at a different trend line, just to show you that the trend line doesn't have to be just a really straight line. That we might be able to model this data to a curve. So a spreadsheet program like, say, Excel or Google Sheets can create a trend line for you And it can even show you the function or the equation of the curve. We'll do a lot more on that a little bit later. Now let's look at some graphs of basic functions. And perhaps we'll be able to do some modeling of our data to some basic algebraic functions. Well, let's start out with our basic linear function here, back from Algebra 1. And actually, y equals x, we can expand this to our old friend, our equation of a straight line, y equals mx plus b, where m is the slope and x is the horizontal, whatever's on the horizontal axis. Mostly what we'll be seeing in looking at motion is that the horizontal axis will be time. Now this shows direct proportionality. As x gets bigger here, y gets bigger by a factor of m. Here's another one, a polynomial or a quadratic. Now we won't have to solve these mostly in our class, but we'll want to know what they look like. So it basically is that whatever's on the horizontal axis is being squared. It's also direct proportionality. As x gets bigger, y gets bigger by the square of x. Another shape that we'll want to be able to recognize is the square root function. It's a direct proportionality, but now as x gets bigger, y gets bigger as the square root of x. Now we've seen direct proportionality. Now we're going to look at inverse proportionality. Say the y equals 1 over x. So as x gets bigger, as the denominator gets bigger here, y gets smaller. So as x gets bigger, y gets proportionately smaller. As we see, as we go to the right here, x is getting bigger and y is getting smaller. Now our other inverse proportionality that we'll see is the inverse square, or something that looks like y equals 1 over x squared. So as x gets bigger, we're going to the right here, y gets really, really proportionally much, much smaller. It drops down. Let's summarize what we've learned so far. So graphs help us make sense of data. A good graph should have a title, axes with labels and units, data points clearly marked. It needs a trend line or a best fit line, and the data needs to be spread across each axis. The independent variable should be on the horizontal axis and the dependent variable on the vertical axis. When possible, we'll model our data to basic algebraic functions. These are a few of the common ones: a linear function, a parabolic or quadratic, inverse function, or an inverse square. All right, complete your Cornell notes, rewind, and review as necessary.